Deduplication for backup. Traditional backup solutions do not provide any inherent capability to prevent duplicate data from being backed up. With the growth of information and 24/7 application availability requirements, backup windows are shrinking. Traditional backup processes back up a lot for duplicate data. Backing up duplicate data significantly increase the backup video size requirements and result in unnecessary consumption of resources such as storage space and network bandwidth. Data deduplication is the process of identifying and eliminating redundant data. When duplicate data is detected during backup, the data is discarded and only the pointer is created to refer the copy of the data that is already backed up. Data deduplication helps to reduce the storage requirements for backup, shorten the backup window and remove the network burden. It also helps to store more backup on the disk and retain the data on the disk for a longer time. Data deduplication methods. There are two methods of deduplication: file level and subfile level. Determine the uniqueness by implementing either method offers benefits. However, the results may vary. The differences exist in the amount of data detection each method produces and the time each approach takes to determine the unique content. File level deduplication. File level deduplication detects and removes redundant copies of identical files. It enables storing only one copy of the file. The subsequent copies are replaced with a pointer that points to the original file. File level deduplication is simple and fast but does not address the problem of duplicate content inside the files. For example, two 10 MB PowerPoint presentation with a difference is just the title page are not considered as duplicate files and each file will be stored separately. Subfile level deduplication. Subfile deduplication breaks the file into smaller chunks and then uses a specialized algorithm to detect redundant data within and across the file. As a result, subfile deduplication eliminates duplicate the data across files. There are two forms of subfile deduplication: fixed length block and variable length segment. Fixed length block. The fixed length block deduplication divides the files into fixed length blocks and uses a hash algorithm to find the duplicate data. Although simple in design, fixed length blocks might miss many opportunities to discover redundant data because block boundary of similar data might be different. Consider the addition of person's name to a document's title page. This shifts the whole document and all the blocks appear to have changed, causing the failure of deduplication method to detect equivalences. Variable length segment deduplication. In variable length segment deduplication, if there is a change in the segment, the boundary for only that segment is adjusted, leaving the remaining segments unchanged. This method vastly improves the ability to find duplicate data segments compared to fixed block. Data deduplication implementation. Data deduplication for backup can happen at the data source or the backup target. Source based data deduplication. Source based data deduplication eliminates the redundant data at the source before it transmits to the backup device. Source based data deduplication can dramatically reduce the amount of backup data sent over the network during backup processes. It provides the benefits of a shorter backup window and requires less network bandwidth. There is also a substantial reduction in the capacity required to store the backup images. We have a diagrammatic representation of source based data deduplication where we have the backup client, storage network and backup device where data duplication is done at the source. Source based deduplication increases the overhead on the backup client, which impacts the performance of backup and application running on the client. Source based deduplication might also require a change of backup software if it is not supported by backup software. Next, target based data deduplication. Target based data deduplication is an alternative to source based data deduplication. Target-based data deduplication occurs at the backup device, which offloads the backup client from deduplication process. We have a diagrammatic representation of target-based data duplication where we have backup client, storage network, backup device, and deduplication is done at the target. Data deduplication implementation. In this case, the backup client sends the data to the backup device and the data is deduplicated at the backup device either immediately or at the scheduled time. Because deduplication occurs at the target, all the backup data needs to be transferred over the network, which increases network bandwidth requirements. Target based data deduplication occurs, does not require any changes in the existing backup software. Inline deduplication performs deduplication on the backup data before it is stored on the backup device. Hence, this method reduces the storage capacity needed for the backup. Inline deduplication reduces overhead in the form of the time required to identify and remove duplication in the data. So, this method is best suited for an environment with a large backup window. Post-process deduplication. This enables the backup data to be stored or written on the backup device first and then deduplicated later. This method is suitable for situations with tighter backup windows. However, post-process deduplication requires more storage capacity to store the backup images before they are deduplicated. In a virtualized environment, we go for backup. In a virtualized environment, it is imperative to back up the virtual machine data to prevent its loss or corruption due to human or technical errors. There are two approaches for performing a backup in a virtualized environment. The traditional backup approach, image-based backup approach. In traditional backup approach, a backup agent is installed either on the virtual machine or on the hypervisor. If the backup agent is installed on a virtual machine, the virtual machine appears as a physical server to the agent. The backup agent installed on the virtual machine backs up the virtual machine data to the backup device. The agent does not capture virtual machine files such as virtual BIOS files, virtual machine swap file, log and configuration files. Therefore, for a virtual machine restore, a user needs to manually recreate the virtual machine and then store data on it. We have a representation diagrammatically for traditional virtual machine backup. Backup agent that runs on each machine, backup agent runs on hypervisor, and we have a backup agent to go with it. In the backup agent, if the backup agent is installed on the hypervisor, the virtual machines appear as a set of files to the agent. So, virtual machine files can be backed up for performing a file system backup from a hypervisor. This approach is relatively simple because it requires having the agent just on the hypervisor instead of all virtual machines. The traditional backup method can cause high CPU utilization on the server being backed up. In the traditional approach, the backup should be performed when the server resources are idle or during a low activity period on the network. Also consider allocating enough resources to manage the backup on each server when a large number of virtual machines are in the environment. Image-based backup operates at the hypervisor level and essentially takes a snapshot of the virtual machine. It creates a copy of the guest OS and all the data associated with it, including the virtual machine, state and application configuration. The backup is saved as a single file called an image, and this image is mounted on the separate physical machine proxy server, which acts as a backup client. The backup software then backs up these images files normally. This effectively offloads the backup processing from the hypervisor and transfers the load on the proxy server, thereby reducing the impact to virtual machines running on the hypervisor. Image-based backup enables quick restoration of a virtual machine. We have a diagrammatic representation for image based backup, where we have application server, storage, which is proxy server, and then we have the backup device to go. The use of deduplication technique significantly reduces the amount of data to be backed up in the virtualized environment. The effectiveness of deduplication is identified when virtual machines with similar configurations are deployed in a data center. The deduplication types and methods used in a virtualized environment are the same as in the physical environment.